Stanford University.
Okay, welcome to Stanford CS 193P, winter of 2017. This is developing iOS applications. This is lecture number 17. Yes, and we have a guest lecturer today who's going to talk to us about accessibility. His name is Skylar Peterson. Why don't you come up here, Skylar? It's all yours.
Thank you very much. Alrighty. Good afternoon, everybody. As he said, my name is Skylar Peterson. I am a member of Apple's accessibility team. If you don't know exactly what I mean by that, then don't worry, it's what I'm here to talk to you about today. I first want to thank Paul for inviting us here to speak today. Hopefully you'll find what I have to say meaningful in some way and choose to apply it to your own work in the future. So before we get started, let me tell you just a little bit about myself. I actually graduated from Stanford in 2014. I studied computer science, and my concentration was in HCI. I took this class while I was here, and it's actually one of the reasons that I fell in love with iOS as a platform and why I'm in the job I am today, so thank you for that as well. After I graduated, I spent a year and a half working at an enterprise software company called Citrix, where I worked on 2 different iOS applications. And then a little over a year ago, I made the jump to the accessibility team at Apple, where I focused mainly on iOS. So for today, there's a couple things that I'd like to cover with you. First of all, what exactly do we mean when we say accessibility? And once you understand that, how do you take the tools that we've created for you and apply them to your own work to make your apps accessible? So included in that, we're going to take a look at the UI Accessibility API. We're going to take a look at several vision accommodations that you should consider when designing your applications. And specifically, I'm going to call out dynamic type as an important feature. And at the end, I'd like to discuss some opportunities available to you as a developer in the accessibility space. So let's get started. I'd like to begin with a brief video that Apple produced towards the end of last year.
People think that having a disability is a barrier. But that's not the way I see it. You can catch up with friends.
Ready?
You can capture a moment with your family.
One face, small face, focus lock.
And you can start the day bright and early. You can take a trip to somewhere new.
3 miles to the summit.
You can concentrate on every word of a story.
A bird began to sing. Jack opened his eyes.
You can take the long way home. Or edit a film like this one. When technology is designed for everyone, it lets anyone do what they love, including me.
So the woman narrating and whom you saw featured throughout that video is named Sadie. And she has cerebral palsy, and she was the principal editor on that video, which I think is a powerful example of the way in which technology can empower people with disabilities and fundamentally change their lives. So that is really what accessibility is all about. It's making technology work for everyone, making it accessible for everyone. So let's take a look at some statistics. There are 285 million people worldwide who have some sort of low vision condition or who are entirely blind. There are 360 million who are hard of hearing or deaf. 1 in every 12 men is colorblind in some way. And 1 in 68 children fall somewhere on the autism spectrum. And so what this means is that worldwide there are over 1 billion people that have a disability of some sort. Or in other words, 1 in 7. So by no means is accessibility a small issue. It affects a lot of people. And if your app has an audience of any significant size, you're going to have users that have disabilities. And you should be doing your best to make sure that whatever you're working on works for everybody. So at Apple, we think of accessibility in 4 distinct groups. First of all is learning and literacy, which includes things like autism, dyslexia, and other forms of learning disability. Physical and motor skills, so people that have tremors or Parkinson's and maybe can't make precise movements or gestures. But this also includes people who are paralyzed or have a limited set of digits that they can use to interact with the system. For instance, a single finger or a single toe, or in Sadie's case, her head. Vision, which covers a spectrum of vision impairment from low vision to completely blind, and also includes different forms of color blindness. And finally, we have hearing, which also, like vision, exists on a spectrum from the hard of hearing to the completely deaf. So now our team has developed a huge set of features on iOS that assist in all of these categories. And best of all, they all come baked into the system from the beginning. So they're all on all of your iOS devices that you can turn on, no add-ons required. And as much as I'd like to go feature by feature and tell you why each of these is cool and why it's necessary and solves a problem, we don't have all night, so I'm going to focus on just a couple. But I do encourage you to go and check them out for yourself. You can find accessibility settings on your device by going to General and tapping on Accessibility, where you'll find a long list of all of the features that you can enable on your devices. What I'd like to do now, though, is demo for you one of our most popular pieces of assistive technology, which is called VoiceOver. It's a screen reader that allows blind and low vision users to use a touchscreen by audibly describing elements of the screen as they pan or swipe around it. So without a technology like this, blind users would be unable to use an iPhone, which is why it's really important for you to take advantage of the API, which I'm going to get into in a little bit, so that your apps play well with it. So I have my device here on the home screen, and I'm going to turn VoiceOver on. And what you're going to notice is that it's going to focus on the first element of the screen, which is the Mail app in the upper left corner.
VoiceOver on. Mail. No unread emails.
And it described it to me and told me some extra information about it. For instance, that I have no unread emails. So if I want to navigate between items, if I want to go item by item, I can swipe right or left.
Calendar. Photos. Camera.
And it's going to read to me the description of each item as I go. But if we're on the home screen, which I'm here fairly frequently, I know my way around, I can also just feel my way around the screen with my finger.
Music.
And once I've found exactly what I'm looking for, a double tap acts like a single tap would when you don't have VoiceOver on, so it's going to open music.
Music. Dismiss now playing screen. Button.
Now, because music is a first-party application, Apple engineers have gone through and made sure that all of the UI in that app is accessible. So VoiceOver interacts with this interface exactly the same way that it would on the home screen. I can swipe or find exactly what I'm looking for. Now, VoiceOver, because it is intercepting gestures that are normally used for other things when VoiceOver is turned off, there are analogs for each different kind of interaction with the system that you might need when VoiceOver is turned on. So for instance, with the track scrubber, if I want to scrub through the track, if I don't have VoiceOver on, then I'm just going to run my finger along it, like a slider. But when VoiceOver's on, it's trying to interpret that gesture as me trying to find an element. So instead, we have this adjustable gesture on items that are adjustable, and I can swipe my finger up and down to change the value.
2 minutes. 27 seconds of 3 minutes. 2 minutes. 48 seconds of 3 minutes. 30 seconds.
So those are just some very, very basic examples of how VoiceOver works. It's much more advanced than that when you get into the nitty-gritty of it, and I highly encourage you to turn it on and play around with it and see what the experience is really like for a user who's blind. So where is the information that an assistive technology like VoiceOver uses coming from? Well, it runs in its own process on the system, and it uses the UI accessibility protocol to communicate with other processes and ask them for information about the current element on the screen. So VoiceOver will receive an input, for instance, a single tap, and it will get the currently focused element's description. It will query the current process for predefined pieces of information about that element, and from those queries, it's going to stitch together a user-friendly description and speak it. So let's take a look at the different properties in the protocol that an assistive technology is going to ask about. The first and arguably most important is accessibility element, which tells VoiceOver whether or not the current thing should even be visible to it. And if this is set to no, then obviously it's not going to be an accessible element and VoiceOver will not be able to focus on it. But in the case of, say, a volume slider, which I'm going to use as an example for all of these properties, we're going to set this value to true. Next, we have the accessibility label, which describes what an element is. So in the case of the volume slider, it changes the volume, so we're just going to say volume. And now you may wonder why we don't say something like volume slider. And this is because of this next property, accessibility traits, which is used to define what category an element fits into. So in the case of a slider, it's an adjustable element, so we're going to give it the adjustable trait. This means that when VoiceOver describes it, it's going to say volume adjustable, which means that the word slider is redundant and doesn't need to be there. Accessibility traits are important in other ways as well. So certain traits afford elements certain behaviors. For instance, in my demo where I was showing the track scrubber, that increment and decrement gesture is added because that view has the adjustable trait set to it. So VoiceOver knows that that view is going to respond in some way to having its value increased or decreased. VoiceOver also has a mechanism for navigating the display where a user can say, I want to navigate based on only this kind of item. So for instance, if I had a table view that I wanted to navigate just by its headers, then I could set this in VoiceOver and it's going to go through and only focus on elements in the hierarchy that have the header trait. So it's important that all of your views have the right traits so that they behave as expected to VoiceOver users. Next, we have accessibility value, which you can override if your view has some sort of state. So for example, the state for the volume slider is what is the current percent that my volume is set to. And we're going to return 50%. And finally, we have accessibility hint. So this is another optional property that's meant to provide a more long-form description of what something is or what something does. This is important often for VoiceOver users who have never used your interface before and are trying to learn their way around it and figure out how things work together. But you should never put information that is critical to the user in this description because accessibility hints can be turned off, and therefore a user may not ever hear them. Which they might do to keep VoiceOver from being too verbose if they're an experienced user. So those are the 5 main accessibility traits. Without them, the interface is totally unusable to VoiceOver, and thus the blind and low vision users who rely on it. UIKit views define these properties by default, or most of them do, which means that most of the legwork is already done for you. But what you really need to watch out for is your own custom views. So let's look at some code. Let's say that I have a view controller that has a property image view of subclass myImageView, which is a subclass that I've created. It's just a UI view. It's not a UI image view or anything like that. So it doesn't have accessibility by default. Well, in my viewDidLoad method, I'm obviously going to call super. And then I could do this. I could use dot notation to set each of these different properties. I'm going to say, yes, my image view is an accessibility element. I'm going to give it some reasonable label. And I'm going to give it the image trait, because I want it to behave like any other image would on the system. Now, I probably want to do this in a case where these values depend on an instance of a view. But there may be a case where the value that is returned from one of these properties applies to all view of that kind. So on the subclass myImageView, I could have instead overridden the getter for isAccessibilityElement to always return true. If I know that myImageView is never not going to be an accessibility element, then this is probably what I want to do. Or if there's some internal logic to that class that determines whether or not I should return true or false from here, this is a much better way to do that. And then I can override the setter to just do nothing. And this applies to all of the different properties. I can override them, their getters and setters explicitly. So now I'd like to demo what you've just seen on a sample app that I've been working on. So I'm going to go back over here to my device. I'm going to turn VoiceOver back on.
VoiceOver on.
So you see down here I have this app called Note Cards.
Fail. No one ready. No cards.
It's just a basic app that has stacks of note cards that I can use to test myself. And I need to do an accessibility audit of this app to see how well it works with VoiceOver. So I'm going to start by tapping on the first thing I see, which is that collection header.
Collections.
So as you saw, it read the label collections. But what it didn't say was header. So I have no idea that this thing is actually a label that is meant to be a header for all of the content underneath it. So that's the first thing I need to do is add that trait.
Add. Button.
That button has a sensible label.
Physics. 5 cards.
That seems right.
Image 1. Button.
That doesn't seem right.
Image 2. Button.
And neither does that. So both of these buttons are missing accessibility labels. And so I have actually no idea what they do. And it said image 1 and 2 because VoiceOver, by default, when it doesn't have a label on something that uses an image like a UI button, is going to default to that image's file name as a last resort to try and see if it can get something meaningful out of what this element is. So I need to instead add my own labels to those buttons.
Trivia. 9. Trivia. Trivia.
And if I go in here, I heard that that had the header trait.
Add. Button.
That is a good label.
Close. Button.
And if I come in here,
Cake is commonly attributed to whom? Queen Marie Antoinette.
I notice that these two labels, even though VoiceOver is picking them up, they are picked up as separate elements. And so I don't really have any context for how they work together. One is the question and one is the answer. And it would actually be much better and give VoiceOver users much context if I were to group them together as one element and say, this is the question, this is the answer, so that they can actually understand what's happening in this interface. So I'm going to go over to some code, to my app. The first thing I want to take care of is that header trait, because it's pretty easy. And I have this title label right here, which I'm going to say accessibility traits or equals header. Now I'm using or equals instead of just explicitly equals because I don't know what the superclass of title label, what traits it has added to this accessibility element that it wants to have there. So I don't want to override whatever it's set. I just want to add my own in. So that's what I'm doing there. Next, let's look at this cell and the shuffle and delete button. So I need to add accessibility labels for these. I'm going to come here. I'm going to say shuffle button, accessibility label. Shuffle seems like a reasonable label to give it. I'm going to say delete button equals delete. Those seem to convey to me what exactly these buttons are supposed to do. And finally, I'm going to come to this collection view cell that had the question and answer. And what I'm going to do here is override these methods, or these properties. So I'm going to override his accessibility element to always return true on the cell itself so that the entire cell is the accessibility element instead of each individual label. I'm going to set the label to return question, then the question's text, answer, and then the answer's text. And I'm going to add the button trait to it because that cell is a button where I can go in and edit the card. And I need to convey that to the user. So let's build this.
No cards. No cards. Collections. Heading.
So I've got the header trait.
Add. Physics. Shuffle. Button. Delete. Button.
Both buttons have the right labels.
Trivia. Make trivia. Trivia. Question. The phrase "let them eat cake" is commonly attributed to whom? Answer. Queen Marie Antoinette.
So
Button.
I've got it behaving exactly as I want it, just a few simple lines of code. And that's just a couple examples of some of the issues that you might find in your own apps. So I'm going to go back to my keynote. I also would like to touch on
App switcher. VoiceOver off.
the idea of containers. So aside from the attributes, we also have the accessibility container protocol. So let's say that I am the engineer who's been tasked with coding this view in the calendar app. It's the year view. And I've decided that I'm going to design this view so that each week is its own custom UI view. And within that UI view's drawRect method, I'm going to explicitly draw all of the days of the week. Now, because those views that I've drawn aren't standard UIKit views, they don't inherit accessibility by default. And I don't really have an easy way of setting the accessibility properties on each of them. But what we'd like for them to be is visible to VoiceOver one day at a time, and so that I can navigate them day by day and get a description for each day at a time rather than each week at a time. So what I need to do is create a set of accessibility elements from scratch that overlay these day views and return them as sub-elements of my accessibility or of my week view container. So what does that look like in code? Well, I have this my week view class, which I'm going to explicitly say is not an accessibility element because I instead want VoiceOver to go through and find the sub-elements of it that are accessible. And I'm going to create an array of elements that are UI accessibility element. I'm going to iterate over the days of the week that are in that week. And for each one, I'm going to create an accessibility element with the accessibility container set as myself because I'm the one that contains it. I'm going to set its label to be something sensible for that day. And then I'm going to set this property accessibility frame and container space. Now, this is crucial because it indicates to VoiceOver where the element is on the screen so that when I'm panning around with my finger, I know exactly, VoiceOver knows where it is. So if my finger is over it, it can describe it to me and see that I'm trying to focus on that element. It's also what VoiceOver uses to draw the bounding box. And in case you couldn't tell, this frame should be in the coordinate space of its container. So once I do that, I'll append the element to my array of accessibility elements, and then I will set the property on my week view accessibility elements to be those elements. And what this says is these are all of my accessible sub-elements, and VoiceOver should navigate them in the order that I returned them in this array. So let's take a look at adding that to my sample app. I'm going to go back over here. I'm going to turn VoiceOver back on.
VoiceOver on. No.
So you may have wondered what this shuffle button actually does. Well, it shuffles the cards in a deck and puts them up so I can test them.
Shuffle. Trivia. Heading.
And what I have down here, this little circle view, is just a little UI affordances to indicate to me how far I am through the deck. So if I go to the next card, for instance,
Next question.
it's increasing because I'm filling up the circle with how many cards I've done. However, if I try to swipe to it,
Next question. Next question.
I hear a bonk. And if I try to run my finger, I'm also hearing a bonk. So what that indicates is that when I swiped and did it, it means that there's nothing left on the screen for VoiceOver to swipe to. You've hit the last element. And when I'm running my finger over it, it means that there's nothing below my finger that is an accessible element. But we'd really like that to be accessible to VoiceOver users so they could track their progress through this stack. And so we're going to use accessibility elements to accomplish this. So I'm going to come back over to my code. I'm going to go to this shuffle status view, which is where I've done the drawing of this circle. I'm going to copy and paste. So what I've done here is I've created an accessibility element with myself as the container. I've set its label to be card, whatever the current card number is, of the total amount of cards. I've set its accessibility frame to be the frame of this circle. And in my accessibility elements, because the previous and next button are also part of this status view, I don't want them to be left out from VoiceOver, so I'm going to also include those in my accessibility elements along with the new element that I've just created. So let's see if that worked.
No cards. No cards. Collect shuffle. Button. Shuffle. Trivia. Previous question.
I've got my previous button.
Next question. Button. Card 1 of 9.
So now it's become accessible. And pretty easy, not too many lines of code. Go back. So I'd like to change gears for a minute and talk a little bit about some visual accommodations that you should be aware of when you're designing your app. So the first thing is color. Color is a useful means of differentiating information, but if it's the sole differentiator, then users who are colorblind won't be able to fully understand the user interface. So take, for example, this view in Mail. Our designers wanted the unread and flag messages to be differentiated from each other with circle views that are of a particular color. But to a colorblind user, they can't tell the difference. So what we did is we added a setting in Mail so that you can change flag messages to use shape and color. And what this does is it uses both color and shape to convey meaning so that no user has to be left out. So if you're writing an app that uses color to convey meaning, then you should consider doing something similar. Now, color can also be too bright, distracting, and contrast and transparency and blurring can all have negative impacts on legibility for people that have certain vision conditions. This is the default control center on iOS. And as you can see, color bleeds through from behind and is blurred by the control center's background. But if I turn on the darken colors and reduce transparency setting, we no longer get those colors bleeding through from behind, and the contrast between the colors and the lighter background is much more stark, which means that it's a lot more readable to those users that have those vision conditions. So you can check whether things like these are enabled through these two UIKit functions. And this way, you can adapt your interface to the needs of your users rather than having to try and create some design that, from the get-go, applies to everybody. Now, for this next one, I'm going to say that anybody in the room who gets motion sick from phone animation should probably look away for a second. The device is going to show the standard app opening animation. So you can see that when I tap on music, the app expands from its place on the dock, and the screen swoops in to center on it. But if I turn on the reduce motion setting, I instead get this crossfade. So there are certain people with vestibular disorders that can be triggered by complex motion, which most often results in things like nausea and dizziness. So you should be mindful of any animations in your app, particularly if they cause a lot of movement or are unexpected in some way. You should consider enabling an alternative animation when this setting is enabled, which you can check through a similar UIKit function. Now, the final visual accommodation that I'd like to talk about today relates to typography, and it's dynamic type, which is a feature in iOS that allows a user to scale their font. And I believe you touched on it very briefly. There are many users out there who struggle to use devices because the type is so small or so thin that it ends up blurring together and they can't read it. And this applies to people with low vision conditions, but it also applies to people whose vision has simply deteriorated from age or people who simply need to wear glasses. So dynamic type is meant to help adapt these people's devices to their needs. Now on the left, you see the standard mail inbox interface with the default text. And on the right, I've scaled it up several levels. And as you can see, the interface has adapted itself and the layout as well to accommodate the larger text size. The most common way that you're going to get this behavior is by using this method, preferred font for text style, which is a class method on UI font. When you set the font of a UI label or UI text view using this method, the font will be scaled to the user's preference using the system font. And what you do is you pass through a text style, which indicates what the general purpose of the text is. So titles are large and body is a more standard size. There are these 8 distinct styles that you can pass to this method, and each of them have predefined point sizes and weight sizes to them. So let's look at some code where I use that. So let's say I have my label view, which is a custom UI view, and it has a sub-label or a sub-view that is of class UI label. Now in my init method, I'm going to init that label, and then I'm going to set its number of lines to be 0. And what this indicates to the UI label is that it doesn't need to be limited to any specific number of lines. It can actually grow to an unbounded number of lines, which is important when I'm growing the text size, because as I get bigger and bigger, it's more and more likely that I'm not going to be able to fit whatever text I have on a single line. Now I also need to set adjust font for content size category to be true. And what this does is it tells the label that when the user has changed their font size and my app is open in the background, the label needs to update itself to match whatever the new font that I've changed my size to is. And then I'm going to use that preferred font for text style. Probably just going to use body because it's standard in this case, and then add my subview. Now, what do you do in the case where you want to use a custom point size when you're at the default text size, or you even want to use a custom font, but you still want to support dynamic type? I did this in my own sample app. It uses the bold system font of size method, which is not going to automatically be scaled to the user's preference. So what I'm going to do is I'm going to take advantage of this property on UI application, preferred content size category. And what this tells me is what the user has currently set their font to. Now there are 7 distinct size categories at default. The large size is the default size on iOS. But there are also 5 more accessibility sizes located in accessibility settings that can make the text really, really big. So what would my code for something like this look like? Well, I'd probably create some sort of NS object like my font manager. That would be an object that would manage all the fonts for my app so that I could run everything through it. And then I'd have some method like this where I'd use a font size variable and write a switch statement that changes the value of the font size based on what my size category is set to some sensible value. And I'm going to do that for every case. And then I'm going to use whatever the method I was going to use before, like system font of size or my custom font or bold system font of size, using whatever size I determined was appropriate for the current size class. Now, it's also important that I register myself to listen for the UI content size category to change notification, because I'm no longer using that preferred font for text style method, so all my views aren't going to know that they need to update themselves when the font size changes. So I'm going to register myself as an observer on this notification and just write a method that updates my fonts in some sort of sensible way. So let's move for the final time to my demo app and see what it's like with dynamic type. Now, for this, I'm actually going to exit full screen. And I'm going to bring up this tool in Xcode called the Accessibility Inspector. Now, this is a super useful tool that I don't really have time to go into today about how you can use it. But it's an app that's built into Xcode that allows you to audit your own application for all of its accessibility problems. And there's a great video from last year's WWDC that you can find on the developer website that goes through exactly how you use this app, which I will have a link to at the end of the presentation. But for now, I'm going to attach to my phone and simply use it to change the font size dynamically so that you can see what happens on the screen when I do. So I'm going to come to my stack of cards, and I can see that it already is set to the number of lines is already set to 0 because this label is growing based on how much text I have there as I want it to. But what we're going to see is as I change this value here with the slider, my text isn't updating at all, the content size. So something is wrong. So I'm going to come over here to my font manager. I'm going to look at my app font method, and I see the problem immediately. I'm not adapting myself to what the preferred content size is, and I'm not using the preferred font for text style method. So I'm going to replace that with this, which takes this size, and based on some multiplier that I've decided looks good, I'm going to modify what the font size is based on the size category. And I'm going to return that using my bold system font of size. Now, like I said, I also need to register for that notification so that my view actually updates itself in real time. So we're going to go to that cell. And I'm going to add myself as an observer, not put that there. And in my content size category change method, I'm just going to update the fonts here. And that should work, hopefully, so let's rebuild. So I'm going to come back over here. I'm going to open this, and I'm going to bring up my accessibility inspector again. And now as I change the size, you see that it's growing bigger and bigger until it's real, real big. And everything works exactly as I was expected to. And not a huge change. So I've covered several ways that you as a developer can make your app more accessible to people. This can actually be a great way to get your app featured on the store. So we have sections that are devoted specifically to general purpose applications that we think have done a good job with their accessibility. For instance, this collection of apps that are good to use with VoiceOver. But beyond making your own app accessible, there's also a whole set of apps that are aimed at accessible users specifically. So I'd like to run through a few of those examples with you today. We have KNFB Reader, which is an app that scans text in real time and lets users who are low vision or blind interact with things like paper or a restaurant menu so that they can read it. We have an app like Ava, which transcribes conversations in real time so that a user who's hard of hearing or even deaf can follow a conversation easier. And this includes a feature that actually breaks a conversation down, differentiating the different speakers by color so I can tell who is speaking. And finally, we have this app, Children with Autism, which is a visual scheduler built specifically for children with autism and allows them to be more independent and understand what they need to do during their day as they're going along task by task. So these are just a couple of examples. And you may wonder, why am I telling you about this? Well, basically, if you're looking for a possible idea for a class of what you might want to work on, or the next great thing that you think you want to work on, I encourage you to check out some of the work that's being done in accessibility, because there are a lot of problems that still aren't solved and that are worthwhile to tackle. Now, I've covered a lot today, and there's more that you can find on the web. These are a couple of links to some resources that you might find useful, including some of the things that I spoke about during the presentation today. In particular, I'd encourage you to check out some of these WWDC videos, including the one on inclusive app design, which is a whole session on design focused on both accessibility as well as internationalization. And that auditing your apps for accessibility, which goes through how to take advantage of the accessibility inspector to make your own apps accessible. So in closing, I'd like to circle back to the why of it all. Why should you take the time to do something like this? Let me read you this quote from Sadie, the woman from the video that I showed at the beginning. "My love for technology is more than just a passion. It gives me access to my world. I need help in some areas, but assistive technology enables me to communicate with my loved ones and pursue my career. What everybody else can do with a keyboard and a mouse, I can do with my 2 switches." The common person's life is enhanced by technology, but for somebody like Sadie, technology is transformative. It can make them independent in ways that really couldn't have been imagined 10 years ago. It can allow them to do jobs that they couldn't have done, have hobbies that they couldn't have had, or experience the world in ways that they couldn't have. So by taking the time and putting in the effort to make sure that the work you do works for everyone, you can have a lasting, meaningful impact on people's lives. I promise you that you'll never find a more loyal customer than the one whose life you made better. Now, I know that some of you may be thinking that that's great and all, but there are some things that really just don't work with accessibility. And I challenge you to think different. If you'd asked somebody 15 years ago how a blind person could use a touchscreen, they probably would have told you that they couldn't. And that's not true today. Anything is really possible when you put your mind to it. So this is a video of my colleague Ryan DJing at last year's WWDC, where we awarded the app DJ Pro for their work on accessibility. He DJ'd live on stage using the app with VoiceOver, and I'd like to play this brief clip for you now.
I have an iPad Pro running DJ Pro and this external mixer. I'm going to go ahead and throw on my headphones now. So here's the thing that's interesting. The external DJ controller acts as an extension of the on-screen UI. And so I can use it to really create kind of a pretty cool performance. Also, you're probably wondering, what of this can I see? Not much. I pretty much can see the light coming from the screen and some of the colorful lights coming from the DJ controller, but that's about it. So knowing that, we're going to use VoiceOver to control this interface. Let's go ahead and get the music started.
Play, deck 1 button. Play, deck 1 active.
Okay, so the first thing I'd like to point out is that I have access to information I've never had before. For example, the time. How much time is left on this track? Let's find out.
Time, deck 1, 2:56.
It's perfect. Okay, so I'm the DJ. I'm supposed to keep the music going, and now I have that kind of information. I also can use these tempo sliders. For example, if I touch it right now, hold on a second.
Pitch bend minus, tempo, deck 1, 0% adjustable.
So we hear it set its standard playback speed, but if I slow it down using the DJ controller, and I touch it again,
Tempo, deck 1, minus 7.1% adjustable.
we can hear exactly how far I've slowed that track down. That's really cool. I also can use these multi-dimensional effects pads. For example, if I touch it the first time,
Effects pad, deck 1.
but the second time. Really cool stuff, right? So between these effects pads, this external controller, and all of this accessible UI, I can do a pretty cool performance. So I'd like to go ahead and ask the stage crew to please take VoiceOver off of the PA system so that it's only available to me in my headphones.
Play, deck 1.
Cool, thank you very much. And I'm gonna mix for you now. Here we go.
So because of the effort that their team put in, people with vision impairments like Ryan can DJ just as well as anybody else. It's something that he loves to do, and it's only possible because somebody at that company decided that it was worth it. Now it's your turn to decide that it's worth it. Thank you.
For more, please visit us at stanford.edu.